Samsa. So then our fifth period. In the last period, we have learned about combination reaction. And here, today we are going to talk about decomposition reaction. Decomposition reaction. Now remember, in a combination reaction, two or more reactants, they combine together to form a single product. Such types of reactions are called as a combination reaction. And here, in a decomposition reaction, a single compound undergoes change to give us two or more products. And these types of reaction is called as a decomposition reaction, where a single compound splits up into number of compounds, new compounds. These types of reactions are called as a decomposition reaction. A reaction in which single compound undergoes two or more products or two or more new compounds. Such types of reaction is called as a decomposition reaction. Such a reaction is called as a decomposition reaction. Say, for example, I am going to give you an example. Ferrous sulfate. Ferrous sulfate. When this ferrous sulfate is heated, we are going to get ferric oxide, and then there is an evolution of gas like sulfur dioxide and sulfur trioxide. Such an evolution of gases takes place over there. And in this evolution of gas, you will get a particular characteristic sulfur smell. Musi sulfur musi. Musi Timothy lost for a pepper mandachi, or the Timothy place. Ferrous sulfate on heat these types of decomposition reaction is called as a thermal decomposition reaction. This is a thermal decomposition reaction. These types of reaction is called as a thermal decomposition reaction. Yeah. Again, it is skeletal chemical equation. You must balance this chemical equation. Now, to balance this chemical equation, iron 2, so you have to place 2 here. When you place 2 here, iron balances. Now, what about the sulfur? There are 2 sulfur in the reactant, and we have a 2 sulfur in the product. And there are, say, 4 2s are 8 oxygen over here in the reactant, and we have a 3 plus 2, 5 plus 3, 8 oxide in the product also. Now equation is completely balanced. Okay? Now let me take you to another example of thermal decomposition reaction. Here, when this say calcium carbonate calcium carbonate, when it is heated, when you heat this calcium carbonate, you are going to get calcium oxide and carbon dioxide. Again, it is another example for decomposition reaction. Thermal decomposition reaction. Then I should say the lead nitrate. Lead nitrate heat in a lead nitrate. Lead nitrate. Here the valency of lead is 2 and lead nitrate on heating, thermal decomposition, you are going to get lead oxide. Lead oxide and you are going to get nitrogen dioxide. And you are going to get water, or not water, you are going to get oxygen over here. When this nitrogen dioxide, it gives a black fume. Not black fume, a brown fume. And it is a particular, characteristic fume that makes this reaction very important. So there are particular gas, your brownish gas, the reaction. Now to balance this equation here, equation the balance here, lead, the nitrogen. So oxygen has 6 oxygen are here. We have only 5 oxygen. 2 plus 2, 4 plus 1, 5 oxygen. That means make it even. To make it even, you can multiply here by 2. When you multiply this by 2, lead becomes, number of lead element over there is 2. So balance it by pressing 2 here. Now, gradually you are going to get here 4 nitrogen. 2 already over there. 2 multiplied by 2, it is 4 nitrogen. And here only 1 nitrogen. So place 4 over here, 4 nitrogen. And oxygen will automatically get balanced. Here, how many oxygen are here? 3 2 is 6. 6 into 2, that is 12 oxygen. Here we have 2 oxygen. 2 plus 8 oxygen, 10. 10 plus 2 oxygen, 12 oxygen. So equation is already balanced. These are called as a thermal decomposition reaction. Similarly, so electrodecomposition reaction. Electrodecomposition reaction. A decomposition reaction where electricity, electrodecomposition reaction, electricity, electrolysis of water. When water, if you pass current over the water, you are going to get what? Hydrogen. It will break up into hydrogen and oxygen on passing current. You might be remembering those electrolysis methods you have learned in class 7. So water, when exposed to current, it splits up into hydrogen and oxygen. These types of reaction is called as a electrodecomposition reaction. Similarly, photodecomposition reaction. Photodecomposition reaction. Or photolytic reaction. Photodecomposition reaction. A reaction where, here, say silver chloride, AgCl, silver chloride, when exposed to sunlight, this silver chloride, which is a white substance, that gets converted into silver, which is a gray substance, and chlorine gas. Here, as we have 2 chlorine over here, balance it like this. It is already balanced. Similarly, silver bromide. sunlight, exposed to sunlight, you are going to get silver and bromine. Silver bromide. Again, 2, that means balance it like this. You have to balance the equation. Now this is completely balanced equation. So, photo decomposition reaction, electro decomposition reaction, thermal decomposition reaction, these are examples of decomposition reaction, where a single compound undergoes change to give us 2 or more new compounds. Such types of reactions are called as a decomposition reaction. Is that clear? So, in this 5th period, what we have learned is decomposition reaction. There are 3 types of decomposition reaction. One is, say, thermal decomposition reaction, another is electro decomposition reaction, then last one is photo decomposition reaction. There are 3 decomposition reactions. Okay, thank you. Umamsa, something tupa. Something tupa lamanso, displacement reaction. Displacement reaction. Displacement reaction. First types of reaction we have learned about combination reaction. Second types of reaction we have learned about say decomposition reaction, and now third types of reaction, it is displacement reaction. In this displacement reaction, more reactive metal displaces less reactive metal. A reaction in which more reactive metal displaces less reactive metals from the salt solution. A reaction in which more reactive matter displaces less reactive matter from their salt solution. Such a reaction is called as a displacement reaction. So here you should know which metals are more reactive and which metals are less reactive. And in class 8 you have learned about activity series. From the activity series you will know the reactivity of the metals, more reactive and less reactive. Now let me remind you activity series. Okay, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. These are the metals in decreasing order of their reactivities. And more reactive metals are there on the top of this activity series, and least reactive metals are there at the bottom of this activity series. Okay, let me write it again here. Kaluyong came mounting a zebra. Iron, hydrogen, silver, gold and platinum. So here, this one is activity series and decreasing order. Metals in the decreasing order of their reactivities. More reactive metals are there, or most reactive metals, they are on the top of this activity series, and least reactive metals, they are at the bottom of this activity series. From here you will know which metals are more reactive and which metals are less reactive. From the activity series you learned in class 8, so I've reminded you this activity series. And here, if I take example of displacement reaction, what will happen if you place some copper sulfate solution in an iron tin or iron cane? What will happen? Now this is the question here. As iron is very reactive and it is more reactive than copper, iron from the wall of this container reacts with copper sulfate which is placed in that particular container, and slowly you will find that there are small holes, lots of small holes appearing on those iron cane or iron container, and it is just because of displacement reaction. Here, if I write down in form of equation, iron copper sulfate solution, or in a beaker, if you place a copper sulfate solution and if you put iron nail in it, you will find that iron nail gets rusted, or iron nail gets decomposed, because the iron from the iron nail reacts with this copper sulfate solution to form iron sulfate solution, and you will find copper which gets deposited at the bottom of the beaker like this. So this is the equation that explains all this. Here, iron is more reactive than copper, so iron displaces copper and there is a formation of iron sulfate and copper. How do you know that reaction is taking place? By looking at the change in state of iron being decomposed completely, and then here change in color. Copper sulfate solution, it is a blue, and iron sulfate solution is a blue-green. It is blue-green. Greenish solution. So here, due to the change of color, you can say that reaction is taking place. Due to deposition of this copper, you can say that reaction is taking place. So iron is more reactive than copper. It displaces copper from a copper sulfate solution. Such a reaction is called as a displacement reaction. Okay, if I take another example, here you don't have to balance the equation. Here you don't have to balance the equation as it is already balanced. One iron here, one iron. Copper 1, copper 1. Sulfur 1, sulfur 1. Oxide 4, oxide 4. Completely balanced. Okay? Now if I say here zinc, when you react zinc with iron sulfate solution, you are going to get a zinc sulfate and iron gets displaced. Here, now this green solution will get converted into colorless solution, that is zinc sulfate solution. Zinc is more reactive than iron. Zinc is more reactive than iron. Zinc is on the top of this iron, so zinc is more reactive than iron. Therefore, zinc can displace this iron over there. And this types of reaction is called as a displacement reaction. What if more reactive metals, when more reactive metals which has a solution, say iron sulfate, and if you place less reactive metal over there, what will happen? Here you can see no change, no reaction taking place. So you can write down no reaction. You have to simply put that no reaction, because copper is less reactive than iron. Therefore, copper cannot displace iron from this iron sulfate solution. Similarly, iron cannot displace zinc from zinc sulfate solution. Therefore, it is also no reaction. No reaction. No reaction. So, this is how you learn about the displacement reaction. There are many types of displacement reaction, and practice them all. Thank you.